Hi everyone, my name is Isaac from the Innovation Consortium, and today I would like to share with you about V-belts, what they are, their basic definition, the purpose they serve, where to use them and how to use them, and how basically to specify them, and basically the different types of the V-belts. To start with, a V-belt, they are just transmission belts we use to transmit rotary motion in machines. By rotary motion, by transferring rotary motion, what do I mean? Take for instance, if I have a motor and I want a motor maybe to drive a certain spindle, I'll put a V or a pulley on a motor, then I place the V-belt in the pulley. Then the V-belt transmits the motion to the pulley of the driven maybe spindle or gearbox or reducer, anything. So when I talk about the V-belts, they move hand in hand with the pulleys actually. So you can't talk about a V-belt without talking about a pulley. So basically it's transmission of motion, but by use of the belts. So ideally that's the basic definition. That's how I can define for you a V-belt as to understand it. With me here in my hands there is a component I've been having since the start of the video, and this is what we call the V-belt. There is another piece, there is also this one. These are all V-belts. Why they are called V-belts? It's because when you look at the cross section of the belt, this type of belt, you'll notice that it's in a V form, the cross section. If you could cut it and you see the cross section, but ideally, if you can see and look closely, the cross section is in a V form. So the trapezoidal, shape in the V-belt makes it be called the V-belt, because a trapezoidal shape looks like a V, more of a V. That's why we call it a V-belt. Now to talk about, remember today we said we are talking specifically about the V-belt, the V type of belt. To talk about the different types of the V-belts, there are basically two most common types of V-belts. There is this plain V-belt. For it, it's plain. It's a trapezoidal, but it's plain. The outer edge, the inside edge, and the slopes, they are all plain. It's the V-belt actually, as you can see the cross section. Then the other one, there is the cogged V-belt. Why cogged? It's having the cogging inside, or the teeth-like structures inside the inner surface of the V-belt. So we have a cog and a V-belt. So this is a cogged V-belt, and this is just a V-belt, as you can define it. So basically, those are the two most common types of V-belts we can see on machines or any other appliances, but basically they are always machines. So after knowing the two common types of V-belts we have, I'll be talking about the specification of the V-belts, so as to understand maybe before purchasing or when designing a machine or anything you're doing but you need a V-belt. The specification mostly with V-belts comes with the class, the classing of the V-belt, plus the dimensions or the length, or to sum it up, they are the dimensions of the V-belt. What do I mean by the dimensions? I'll be explaining furthermore the dimensions. But first of all, let's talk about the classes, the different classes of the V-belts. As I had said earlier on, you can't talk about the V-belts without talking about pulleys. As we saw in our videos or in the video of pulleys, the same applies to the V-belts. V-belts have the same classes as pulleys. There is class A, there is class B, there is class C, D, and so on and so forth. There are more designs which have been brought into, but those are the most common types of, actually, the classes we know. There is A, B, C, D, and very many other types. So basically, I'll basically talk about the four. So as you get the clear image on how an A-class pulley, of how an A-class belt, a B-class belt, a C-class belt, and a D-class belt, the dimensions, and basically the cross-section. So the dimensions are more or less, or they are the same as the dimensions of the pulleys. An A-class pulley is the same, has the same dimensions as an A-class belt. Reason being, for a pulley of an A-class, the belt will be sitting into the groove. The A-class belt will be sitting into the groove of an A-class pulley. So the dimensions of the V or of the cross-section will be the same for the pulley and the belt. I'll give an example. I have a pulley here with me. This one is a B-class pulley. So you will notice I'm also having a B-class cogged belt or cogged V-belt. So the dimensions as I said earlier on, they have to be the same because a belt and the pulley, they move hand in hand basically. So to the explanation, you can't talk about a V-belt without talking about a pulley. So when we talk about the classes, a class A belt will be meshing into the grooves of an A-class pulley, and a B-class belt will be meshing into the groove of a B-class belt, of a V-class pulley. So we can take a view. I'm having a B-class V-belt and I'm having a B-class pulley. So we shall try to put the belt into the groove so as we see clearly what I'm talking about. So if I place the V into the groove, as you can see, you'll notice that the V cross-section of the pulley and the V cross-section of the belt are meshing. As you can see, the belt is even flashing. So basically, that's what I mean by the specification according to the size or according to the class basically of the pulley. So we have class B, class A, class C, class D, and they only differentiate or they only differ in the sizes of the cross-section. I'll furthermore explain, though I had explained the cross-section with the V pulleys. So I'll re-explain with the V belts so as we fully understand the classes and their particular sizes. So a class B will be of the same size as the groove of a class B pulley. A class B V belt will be of the same size as a class B pulley. So it's the cross section which is always the same basically. The dimensions are the same. So to re-explain about the dimensions, the class A is 13 millimeters at the top of the edge, at the top of the belt from here to here. If you get your caliper or tape measure or any measuring instrument, once you measure the top edge, it will have to be 13. The height will have to be 9 millimeters. The height, I mean, from here, the edge to the bottom. So the height, if you measure from here to here, it will have to be, for an A class V belt, the height will have to be 9 millimeters. So furthermore, if we go to a B class V belt, the distance from edge to edge will have to be 17 or 16.5 millimeters. Remember, we said on the pulleys that we only have a tolerance of 1 or 0.5 millimeters. That's the difference, or the allowable difference between the dimensions. For a class B, we shall be having 17 millimeters. Then the height of a class B pulley has to be 12. Then remember, we are talking about the inclination angle. I had not talked about it. The inclination angle is always the same. It's 40 degrees for the V-belt and the pulleys actually. So it's always the same, the inclination angle. That angle, I mean the angle, the slope you can see here in the cross section of the V-belt basically. So to talk about the C-class V-belt, it's also the same dimension as the C-class pulley, but to re-explain about the dimensions of the C-class V-belt, if you measure, I'm using a B-class V-belt, but I'm trying to show you the clear image or the spitting image of what the V-belt or the dimensions have to measure. So once you place the caliper on a C-class, here it has to be measuring 22 millimeters. Then the height 14 millimeters. Then the inclination angle, it has to be 40 degrees. 22, then 14, then from 14 the inclination angle is 40 degrees. That is a C-class. Then if you go to the D-class, edge to edge, for it has to be measuring 32. Those are millimeters. Then the height has to be measuring 19, those are millimeters also. Then the inclination angle is still the same, which we said it's 40 degrees. So basically, they are more or less the same, or the dimensions are the same, depending on the classes, in both the V-belts and the V pulleys actually. So basically, that's the specification in the cross section. So after knowing the specification of the cross section of the different classes of V-belts, now the other specification is about the length, and how do we ascertain the length, or how do we measure the length? Assuming I don't have one, but I know the distance or the circumference in which I want to place the V-belt. So basically, I'll talk about the tools we can use to measure the cross section of the V-belt, considering I don't have one, or I'm to purchase once a V-belt has got broken or worn, or any damages have occurred on my V-belt. How do I measure the dimensions? The first tool maybe you can have is a flexible measuring tape or tape measure, but it has to be flexible. Leave alone the hard one or the metallic ones we use in fabrication. It has to be a flexible measuring tape. So you place the flexible measuring tape on the outside of the V-belt, on the outside circumference of the V-belt. The reading you get, it's always in inches. The reading you get is the length of the V-belt. So take for instance, I'll be using a tool. This particular tool, it's just a string, a normal string, a nylon string. So I'm going to use a nylon string to measure the circumference of my V-belt. So I just place the string at the start of the V-belt. Remember, we say the outside or the outer circumference, it's where we put the string or the flexible tape measure. So I place it on the outside. I make it rotate from the starting point. I make it rotate to the outside, to the outside of the I make it rotate the outer circumference of the V-belt, and where it stops, it's where I hold it from. Take for instance, this one has stopped here. Now after knowing it has stopped here, I pinch, then I let it straight. These dimensions, I just lay them on the tape measure. The dimensions I get, it's the size or it's the length or it's the circumference actually of the V-belt. Now I'll get my pulley, I get my tape, I roll it out, a steel tape, then I place on to the start of the tape measure to where I held. It's showing 44, meaning if the belt is class B and the length is 44, ideally it means it's a B44 type of pulley I'm having, or it's what I want basically. So that's how we measure the length of a V-belt. The reason as to why we talked about not using a hard steel tape measure, once you place a hard steel tape measure, it will make wrinkles, making the dimension be actually affecting the accuracy of the dimension or the length or the circumference we are trying to ascertain. The wrinkles you get, they are always adding in minor millimeters or inches, which will affect the final reading of the circumference of the V-belt. So we always use a flexible one or a string. Then from a string, you place the dimensions of the string on the hard tape measure to get the length of the tape the circumference of the V-belt. So basically, that's the V-belts for you. I remain Isaac from the Innovation Consortium. Thank you very much.